Now let's look at add for circular linked list. Once again, create a new node. And if the list is empty, then we're going to set it, the list, to the new node. And also, this is a circular linked list. We need to, this is a new node, right? We create new node. Set list to new node. That's the first thing. Second thing, we're going to have to make the link back to itself. Right? So new node, set link to new node. Or to list. Once already set. Now also the second case, this is like if it's empty. If it's not empty, we create a new node. And then after that, this one is say I always add to the end. This is like queue. Right? So if I always add to the end like queue, then first set new node dot set link to list dot get link. Then we set to the head, right? Set the link to the head because list dot get link get your head. Correct? Second, you have to link, right, the list to the new node. So which is list dot set link to new node. Third, you have to move your list. List equals new node. So those are the steps, right? 3 steps. So let's look at how we're implementing it all together. So first we check the scenario list if the list is empty by list equals to null. Always create new node first, right? No matter what. If list equals to null, then like we said, list equals to new node, and new node is set link to list. Else that means it's not null, we add to the end. Then we set the link of new node to list.getLink. And then list.setLink to the new node, point to new node. And move your list to new node and increment your number elements. So next is about doubly linked list. So what's doubly linked list? Doubly linked list is normally our list just travel one direction. Now we can travel backward instead of forward. So this is called doubly linked list. So you can travel forward, travel backward. So that means your new node actually, instead of have the values, or I call elements, and the pointer to the back, to the front. Now we also need the pointer to the back. When you do this, you no longer need previous. But new node, you need to have 3 attributes. So that's why we're going to create a new doubly linked list node extends from linked list node that add back pointer. Now in your test, you're going to see circular doubly linked list. So at the end, it's going to circulate back, forward, and backward. So we said we need to add back pointer in this case. Then whenever you create a new node, now you have 3 elements: back, front, and the element itself, right? 3 attributes for that node. Then we're going to override the constructor of our node using super. Initialize. Right? and then set the pointer back equals to null. Now we have to have set back, take the pointer in, and this dot back equal to back, and get back return back. Now let's look at where we add something into the doubly linked list. And this is the ordered list. So we found the location where I want to add Liel, which should be ordered before Miriam and after Joshua. So what is the first thing to do? We create new node. So after we have new node, we are set back to Joshua. And how do we get that? Location dot. We have get back, right? So location dot get back give you Joshua. 2, we will say new node, right? Has dot set back to location dot get back. Something like this. Location dot get back. This is giving Joshua, correct? And new node dot set back to location dot get back. So that's number 1. Now number 2, we have to set new node dot set front to where? Location. So that's number 2. Number 3, we have to break it on links, original links, by getting Joshua point to new node, right? And Joshua is what? How do we get Joshua? Location dot get back. Now we get Joshua, right? And set back again, right? Pointer of Joshua had to point to where? New node. So that's number 3, right? And number 4 is like we have to set front. Location and get back, and then set front of Joshua. Yes, to new node. And number 4 is location itself, right? Dot set back to new node. So those are the steps, right? When you add. How about remove? In Doubly, right? Linked list. So let's look at remove. When we remove, we found, for example, we want to remove Joshua, right? So we found location Joshua, we have pointer location. So when we remove, we pretty much just do the same. Set the front pointer to location.get next, right? Get front in this case, right? So that's the first step. How do we get that debit? We have to do location dot get back first, right? And then dot set front to location dot get front. Right? Because location dot get back get debit. So this is debit. And then debit dot set front to the new location dot get front. So that's how we link. Now we link that front, we also have to link the back. So for Miriam, so we gotta do how to get Miriam, location dot get front, we get Miriam, right? And set back of Miriam to where? Location dot get back. So that's how we remove, right? So now we understand what's doubly linked list. Next one is linked list with headers and trailers. So what's that? The header node is a placeholder node. We just make a placeholder and at the beginning of a list. And we used to simplify list processing, like this is gonna hold the smallest values. That's why it's A, and trailer node is going to hold the end of the list values, the largest values. This is easy, right? So what's the benefit of using the placeholder, header, and trailer? The benefit of having header and trailer is when you write a code, you don't have to worry about, is this an empty list? Is this removing from the end, remove from the beginning? Because that's more complicated. You have to think about when you write a code. There's so many scenarios you have to worry. And that could make your code errors, right? Prone. So when you have this, you always know that it's going to be just insert in between. So your code just supporting that logic. Make it simply to write the code and it's more efficient in your code. Now a linked list as an array of nodes. So in this section we're talking about, normally when you write the code for a linked list, you look at new node and create a pointer, right? Pointing to each node in the list. This is like dynamic storage, right? Whenever you need, you create a new node and set the links. But you can also implementing linked lists using an array. Okay, this is static storage. And why do we need to do that? Because some programming, like this is just data structure concept. You don't need Java. We happen to use Java to in this class to write a code. But some languages, they do not have concept of pointers that they're supporting like this. Then if they want to use linked list, they can't. They have to use array. Okay. So let's see how we do that. So this is an array, right? Size of array is 7, 0 to 6 is an index. So when you set the head or the first, we can set at index number 2. This is an ordered list, so let's go to A. And also, it stores the values of the next, right, indexed, which is to next values, which is index 1. So let's jump to 1, B. B store the values to the next index, which is index 6, which is C. And C store 4, which is D. And when we get to -1, this is like null. That's at the end of the list. So another reason why you want to use an array is sometimes managing the free space ourselves gives us greater flexibility. An array will allow you to do that. And there are times when dynamic allocation of each node one at a time.